this is the second video of repeated measure ANOVA. Let's consider an example that an investigator is interested in comparing the cardiovascular fitness of elite runners on 3 different training 10-mile course. Course 1 is flat, course 2 has graded inclines, and course 3 includes steep inclines. 10 runners' heart rate is monitored at mile 5 of the run on each course. Note that there are 3 courses we want to compare, and all 10 individuals' heart rate are repeatedly measured. There is a snapshot of the data on the bottom left corner. We sometimes call this wide shape. The course 1, course 2, course 3 has each column, so it has a little bit of wide shape of it. Often, we want the independent variable to be one column rather than multiple columns. Then we want the data to be in a long shape, like on the right bottom corner. Of course, if it's only a part of the data, and this will continue till there are the individual 10. So here is 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, and it will go up till 10, 10, 10. And notice that the courses is a one variable, and it says 1 or 2, the course 1, course 2, or course 3. And then heart rate has another column there. So this will make the total sample size of 30. To run repeated measure ANOVA and other summary statistics, we can install and load the following packages. First, we import data using import button on RStudio. The data set is available with the module, and you can first save them on your own folder and import it using read.csv function, which automatically generated from import button. Now we can get a summary table by using get underline summary underline stats function, which is a function in our statistics package. For the different group variable course, get underline summary underline stats function will return the sample size, mean, and standard deviation with the mean underline SD type. So with this type, we'll actually generate sample size and mean and standard deviation. The summary stats here at the bottom, the results of the heart rate are organized for 3 different courses. It looks like course 3 has the largest mean, followed by course 2, graded incline, and the course 1, which is flat. Standard deviation is higher for the course 2 and course 3 and course 1 in that order. The similar pattern can also be seen in the box plot. Using ggplot, we define the data H rate, X variables to be course, and Y variables to be heart rate. Notice that we ask R to treat the variable course as factor, not a numeric number, as it is written. Then draw box plot with sky blue color. In the box plot, it shows the course 3 steep incline has the highest median heart rate, followed by course 2 graded incline and course 1 flat. The variation is highest in course 2 and closely followed by course 3, and variation is slightly smaller for course 1. The repeated ANOVA can run using ANOVA underline test function. Okay. And this is also in our statistics package. Notice that the parameter dv is response or dependent variable. And here, heart dot rate will be our dependent variable. WID is subject variable, and here runner dot number will be the subject variable, and within is a group variable or treatment variable. So here the course will be our treatment variable. The RMH rate, which is the results of ANOVA underlying test function, has a list of repeated measure output. One of them is ANOVA table. So if you type RMH rate $ ANOVA, this will provide the ANOVA table in the first gray box right here. It is a short version of full ANOVA table, and will generate the full ANOVA table in the next slide. Meanwhile, the null hypothesis here is the mean heart rates for all three courses are the same, and the alternative hypothesis is at least one of those means is different. With F-test statistics 15.601 and corresponding p-value 0.000117, which is smaller than the significance level 0.05, we reject the null hypothesis and conclude at least one of the means is different from the rest. Get underlying ANOVA underlying table function will also generate ANOVA table. And the results is in the second gray box. A lot of the values are kind of similar, but there are a bit of discrepancy, such as your degrees of freedoms are a little bit different. The p-value still smaller, but there's a little bit of differences there. And this is because the get underline ANOVA underline table function automatically corrects for eventual deviation from the sphericity assumption. We're going to talk about that later. And we can just call that equivariance assumption, but a little bit of a fancy word for that. We'll talk about it in the assumption checking more in detail, but this is practically very useful function since it automatically corrects for the violation of the equivariance assumption. So in a way that if you're using this function, we don't really need to worry about the particular assumption, whether it meets or not, because it automatically corrects it anyway. So very useful function here, get underline ANOVA underline table. The last column of the output is called the GES, stands for generalized effect size. GES is amount of variability due to the group or treatment. It can be calculated by SSB, so sum of squared of group or treatment, divided by total sum of square, SS total. We'll see how 0.16 is calculated in the next slide. In this slide, we'll compare the repeated measure ANOVA results to the one-way ANOVA results. First, one-way ANOVA is run by using ANOVA of the LM function. Notice that p-value here is 0.09484. And based on that, since this p-value is not less than our significance level 0.05, we fail to reject the null hypothesis, which means we fail to show the mean differences in heart rate among three courses. The bottom table is a regeneration of the full ANOVA table for the repeated measure. So there are quite a few values will be actually look similar to the previous numbers, but it has a more rows with more numbers. Okay. and the yellow highlighted one. So we will copy over a lot of values from here, one-way ANOVA, and the other table as well. And the yellow highlighted numbers are calculated manually. And we'll talk about that. So from the one-way ANOVA here, at the top, we know that SSB is the same in the repeated measure, for the factors. Thus, SSB, which is 476.47, will stay exactly the same for the repeated measure. So I just copied this number 2 at the bottom table. SS total, sum of squared total is sum of squared factor plus sum of squared error for the residual. So if you add those two numbers, that should be SS total. So SS total in the repeated measure and also one-way ANOVA will be 2,975.87. So we can put that number over there. Okay, and then if you look at the degrees of freedom can be calculated based on the fact that n, the number of individual, and k, the number of group, which is equal to 3 here. Okay, then you can see the n-1, which is the degrees of freedom for the between subject is 9, and there are 3 groups, so k-1, which is between treatment, degrees of freedom will be 2, and then your total degree of freedom is n times k-1. This is always the total sample size minus 1, which is 29. And once you know 9, 2, and 29, the degrees of freedom for within should be the leftover from the other one, which means if you add 9 plus 2 plus something, that should be actually 29. So you can actually calculate it as 18. Okay, so MSB can be calculated by 476.47 divided by 2, which is 238.23, same as the mean squared factor in the one-way ANOVA. So here's the same number. From the repeated measure ANOVA table in the previous slide, your F is 15.601 here and here as well. So we copy that number. And now we can calculate MSE for repeat measure ANOVA table. The F is defined as MSB over MSE. So using that equation, we can calculate our MSE as 15.27. So from here, we calculate SSW. So we know this is 18 degrees of freedom and the MSE is 15.27. So the calculation is SSW over degrees of freedom is MSE. So opposite way, we multiply these two numbers, degrees of freedom and MSE, then we can come up with SSE. So if you multiply those two, we're gonna end up 274.86. And now we actually know all this number but SS sub. So again, SS total is the sum of all these sum of squared number. So from 2,975, you subtract these two numbers, we can actually come up with SS sub. So the repeated measure ANOVA table in the previous slide, this one is actually just a short version of what we are actually talking about right here. Our p-value will be 0.00117 based on that. Okay, the generalized effect size, again, GES in the previous slide, is SSB over SS total. So here SSB 476.47 divided by 2975.87, which is 0.16. And we can see this table is extended version of the first grade table in the previous page by using RMH rate, $sign ANOVA. In conclusion, by having repeated measure design, making 10 runners run all 3 courses, we were able to count between subject variation in the model. This made the smaller MSE resulting more powerful test. One-way ANOVA results, we failed to find the significance in heart rate between 3 courses by ignoring the individual variation in a way. And the new p-value with the individual variation counted in the model is 0.000117, and we were able to detect the heart rate difference between 3 courses. Okay, this is the end of the second video.